Hi folks, so the question we're going to be doing here today is based off of the ellipse and the parabola. So it's actually based off this lamp question here. So just looking at the question, always start now to read the question and find out what they say here so we can complete it over here. So the question says, the figure shows the design based on the elevation of a lamp. We can see the 3D graphic of it here. It says the curve ABCD is based on an ellipse with the major axis 150 millimeters long and the minor axis 80 millimeters long, and the focal points E and F. So we can see A, B, C, D. That's the curve of the ellipse. It's obviously not a full ellipse. It's only basically a half ellipse with this portion here. And then we have focal points E and F. And the major axis is 150 from D up to B. And the minor axis is 80 millimeters, but obviously they've only given us half the minor axis here, but we know the diameter is 80, so that means the radius is 40. So straight away, before we even get onto the parabola here, and I'll come back to that in a minute, what I'm going to do is starting with the ellipse. That should be fairly standard for us. Major axis 150, radius 75, minor axis 80, radius 40. Okay, and the ellipse is going vertically. So we'll start with that there now. So as you can see, I have set up my major axis. D, B and C are already points on the curve, so I'd always label my points as well as I'm going along. Okay, so if I have the major axis, I can put in my major auxiliary circle. So I'll pop that in there now, and I'll pop in my minor one, so I'll just speed up the video. And we know at this stage, when we break up our major axis, when we have our minor and major axis drawn, what we're going to do is we're going to split them up into 30-60 degrees. So speed up the video there just once again. Okay, just on completing the ellipse here, just a quick point and a little kind of pointer here. What I would always note is the direction of my major axis. So my major axis in this case is going up vertically. So what I'll just put in is MAJ for major, and I'm going to put in a little arrow going up and down. So that means my major axis is going vertically. My minor is going horizontal, so I'll put in MIN, and I'll put in a little arrow going left to right, so that we know my minor is that way, my major is that way. And we know the method for completing an ellipse at this point is concentric circles method. Where it cuts my minor circle, the lines that I drew in, the 36 degree lines, where it cuts my minor circle, I'm going to go parallel to my major axis. That's why I put in this. And where it cuts my major circle, I'm going to go parallel to my minor axis. Okay, so just quickly on this one, put that point in. So that's going to go up, parallel to the major. And where it cuts the major circle, go parallel to my minor. That helped me locate a point. Now I want to find the rest of the points using this line, and this line. So I'm going to speed up the video there once again. Okay, so we can see that the ellipse is completed there. We know at the very top, I'll just bring up the question here again. At the very top, we obviously have, once we locate our focal points, we have to find A, but I'm just going to do a quick bit of tidying up here, down at the bottom here as well, okay? So I'll just quickly tidy up that, so I'll speed up the video there once again. So, just quickly before I speed up the video, I'm going to locate my focal points. So I need to find E and F. So I get half the major axis, take that distance, go to C, that one will give me E, this will give me F. And the reason I needed them is because I'm going to locate A in a while and I'm going to get the platform down here. So I'll just speed up the video for the platform. Okay, on the next part of the question, we can see that I have the ellipse done. I did my platform, just did a little bit of shading in there, just kind of heavied in that part. The reason I did that is because when I actually heavied in my ellipse firstly, I should have left this bit in hidden detail, so I just shaded it in. On to the next part of the question now. I have located my focal points. I found E and F. And the reason we needed to find E is because E, if we see, is across from here A, which is basically going to be the starting point of our parabola. So if I come back over here to the question, it says, the line AT is a tangent to the ellipse at A. The curve GAH is a parabola with vertex A. It's a bit hard to see there under lighting, apologies for that. So basically what they're saying is, the line AT is a tangent to the ellipse at A. Okay, so first of all I need to find A. So obviously I need to complete this portion of the ellipse here. So straight across from E I'm going to do axial symmetry. I'll take the distance from there across and then project it out here to find A, and then I want to get a parabola. And how do we find a parabola? We join the both focal points to A, extend them on and bisect the angle that's relevant to us. Okay, so I'm going to do that there now. Okay, just on the parabola, I'm going to extend both my focal points through A. I'm going to speed up the video once I bisect this angle in here. Okay, now what we have is we have the line A. What we need to find is T, and if we look at our sheet we can see that T is 40 millimeters away from A. So I'm just going to measure from A there 40 millimeters down, locate my T, which is right there. Okay, now at this point I'm just going to go back to the sheet here nice and quick. Okay, zoom in on the little bit down here. So to create a parabola, what we often need is we need a box. Okay, so I need a box around here, and we can see that A to T is 40. Okay, nice round number that we're going to use to split up our box. And then G to H is 80, and we have T, so that means from T to H is actually half of 80, which is going to be 40. So what we need to do is a little bit of sliding set squares here, and I'll just show you that method there now. So just on a little bit of sliding set squares, what I'm going to do is I'm going to set up my 45 degrees on the tangent A to T, which we found. I'm going to put my 30-60 underneath it. And what I want to do is I want to get lines that are going perpendicular to my tangent. So to get lines that are perpendicular to the tangent, I set it up on the tangent, and then with the set square underneath it, I'm going to rotate this set square around. And there we go. At that point, I'm going to do a line left and right of it, and the exact same at A. Okay, and then at my T, I'm going to measure out 40 millimeters. Okay, and then I'm going to do a parallel line to AT tangent from that point that I measured out. Now this is actually all we need. This little half of the box is all we need actually to complete our parabola. So what we're going to do is we're going to split it up. A to T is my vertex line, so I'm going to split up this line into 4 equal parts and this into 4 equal parts because it's 40 by 40. So I'll measure down 10, 10 and 10, or sorry 10, 10, 10, 10. So 10, 10, 10. And I'll do the exact same here, 10, 10 and 10. Now the ones along here I need to create some cuts going down, so I'm just going to parallel line down to the tangent from AT, the last one here. Okay, and at this point here all these outside points are going to go into A because A is our vertex. Okay, and what we've actually located there is a series of points on our parabola. So I'll extend them down. Drawing the curve. Okay, and at this point here, what we're actually going to do is use a little bit of axial symmetry to complete the other half of the parabola. So if I wanted to find this bottom point here, because that was a point on it, I will put my compass point on there and the nib or the biro point here and rotate it around, find it there on that side. That's a point there. And if I want to find other points, all I'm going to do is a little bit of sliding set squares. So from the point that I found here, sliding set squares parallel to the line here, this point and this point. So the exact same thing, axial symmetry. Take that distance there, mark it out to the opposite side. Same with the next one. and the same with the last one. There we go, folks. That's the question completed there. Okay.